Hi, this is Steve Wimsatt from Ruckus Wireless. I'm going to talk about our Wi-Fi solutions for the higher education market. Colleges and universities must deal with dramatic changes in user requirements, online learning opportunities, and security concerns to effectively satisfy their various customers, including students, faculty, and staff. While society in general is moving to a more mobile network and applications environment, higher education is on the leading edge of this trend. Because of this, they face some unique challenges. In addition to simply covering very large areas around campus, they need to deliver very high density support for large classrooms and auditoriums, and they must deal with an incredibly broad range of devices. This presentation will discuss some of these key challenges and requirements, as well as Ruckus's unique solution to provide high-performance Wi-Fi for higher education. A few years ago, the number of wireless devices passed the number of fixed-line Ethernet-connected devices. This trend simply continues to accelerate. While fixed-line connections still offer many advantages and often higher speed performance, users increasingly want access to their applications, classes, games, and anything else on the network from wherever they happen to be. This fundamentally changes the role of Wi-Fi from being a best efforts overlay network that provides service in selected hotspots to being an industrial strength utility that is expected to be available and working everywhere. Again, these trends are particularly acute in higher education. Students are constantly online, whether for coursework or with social media and their friends. The global campus is becoming a reality. In class, there are more and more resources available to teach lessons, enable group work, and provide additional content. The faculty and administration can also benefit from classroom management systems and operational support capabilities such as IP video security systems and push-to-talk voice-over Wi-Fi voice systems. BYOD and the explosion of Wi-Fi capable devices, students are bringing all sorts of devices including laptops, tablets, phones, game consoles, TVs, and other devices which your IT can't possibly support and really would rather enable with appropriate controls than try to prevent. All these drivers are real, but schools also face very tight budgets and are already overwhelmed with their IT work. Ideally, they need a solution that offloads some of their current time-consuming activities and minimizes the incremental cost. Mesh wireless, for instance, can enable large coverage areas without having to run expensive new cabling to each AP. At the end of the day, schools compete for students, faculty, and staff, and they need great wireless to meet everyone's expectations. So, how do all these user expectations translate into specific Wi-Fi needs? Clearly, higher speeds and more reliable connectivity are table stakes. Today, wireless infrastructure must be able to support very high density usage, such as if everyone in a large classroom or lecture hall gets online at once to watch a video or pull down an assignment, or what might happen inside a football stadium after the home team scores a touchdown. Schools also need to deliver connectivity everywhere on campus, indoors and out, and ideally with as few APs as possible. Strong, simple security that provides differentiated network access based on the user, the device, and the application is critical, and it must be fully enforced and enabled without any IT involvement. Flexible deployment options can also be important so that you can manage your Wi-Fi centrally across campuses or at the campus level, within schools on campus, or in some hybrid combination. Again, all this has to be done at the lowest total cost, including CapEx to purchase the equipment, as well as installation and ongoing management. We call our solution to these challenges smart Wi-Fi. A lot of people think Wi-Fi is pretty much the same, but it's really only the radios that are the same. They all come from 2 or 3 manufacturers. Some vendors try to differentiate beyond that, and at Ruckus we focus on delivering the best possible connections by optimizing signal strength and dealing with interference. This is a very simplified picture of one of our APs. In a large classroom, it might be our 3x3 3-stream 7982, which can support up to 500 users. In a smaller classroom or office area, it could be the 7372 dual-band AP, or it could be an outdoor AP. Regardless of which model, Ruckus APs all have a very intelligent internal antenna system It's all inside that box. We think this is a key differentiator since nothing else really matters in a Wi-Fi system if the user doesn't have a good, usable connection. But in addition to the smart antennas, we also provide some additional smarts, such as meshing. Meshing allows you to deploy APs using wireless backhaul through other access points, so you can provide coverage even in places where you can't run a network-connected Ethernet cable. This can save a lot of installation time and cost, as well as open up entirely new parts of campus for networking. QoS. Different types of applications require different wireless performance. Our access points can automatically sense high-priority traffic, such as voice or video, that may require high bandwidth or low latency, and it automatically prioritizes that traffic stream to deliver the right performance for the application. We also offer flexible management options so you can manage your Wi-Fi infrastructure from one central location or on each campus or each school, whichever works for you. College and university campuses tend to be very large, with many buildings, each of which may potentially include very high-density wireless environments. Our APs provide unique high-density capabilities to handle large numbers of users. They have unique capabilities to steer directional signals to each connected client and constantly adapt to provide the best signal. This provides a higher throughput connection, so user traffic gets off the network quickly, and also reduces interference, freeing the AP to handle more useful traffic. Since the APs constantly adapt to changes in the environment, there's one less thing to worry about from an operational perspective. In reality, it's really the combination of stronger signal strength and adaptive antennas that deliver very predictable performance. At Ruckus, we worry most about worst-case scenarios. How do you always provide the required connection levels so the algorithms built into our APs focus on throughput metrics, not just simple things like RSSI? As you can imagine, this all makes our system much easier and less expensive to deploy, since you need fewer APs, there's more flexibility in where you place them, and you don't need to worry about constantly adjusting them. This slide provides a simple picture that explains how our APs are able to do things like focus energy to each client and deliver stronger signals. And what is the big difference? The picture shows a typical AP, could be from any vendor since they do this the same way, that's on the left, and a Ruckus AP on the right. If you look at the AP on the left, and it could be a 1, 2, 3, or even a 4 radio solution, but each radio is tied to a single antenna. These antennas send and receive in an omnidirectional or 360-degree pattern. There's a couple of issues with this. First, there's a limited number of antennas, 3 in this case, and you need to keep each of them aligned for best performance. Also, their polarity is fixed based on which direction they're pointing, meaning a device must be held at the same angle as the antenna to get the best signal. The Ruckus antenna, on the other hand, includes up to 21 different antenna elements which can be dynamically combined into thousands of potential antenna patterns, each of which provides a directed signal aimed in a different direction. Our software determines which antenna combination delivers the best signal path to each associated client on a real-time, packet-by-packet basis. In addition to dynamically steering around obstacles, this provides some key advantages. First, the antenna pattern that will be selected is always a directed signal, meaning the signal energy is directed in a specific direction versus being dissipated over 360 degrees. So there is more energy directed to the client, and the antennas have better receive sensitivity to listen to clients. Also, the antenna array includes both horizontal and vertically polarized antennas. So no matter how someone is holding a device, upright or flat or whatever, a Ruckus AP will transmit and receive with the optimal polarity for that orientation. We call this feature BeamFlex Plus, and it is particularly important as more and more users connect to Wi-Fi with small handheld devices, since these generally have smaller, less effective antennas. Just to make sure you know what I mean, and we've all done this, when you take your cell phone, for instance, and you hold it up in the air and turn it in different directions and different angles, searching for the best signal, what you're really doing is searching for the best polarity to take advantage of whatever signal is available. With Ruckus, your students, your faculty, and your staff don't need to stand out there looking ridiculous. Our Wi-Fi provides optimal polarity, and they can just focus on whatever they're trying to do. We've talked about steering the signal around obstacles and getting more signal strength from directed antennas. But an equally important benefit is that Ruckus APs can minimize interference since they aren't sending as many extraneous signals off in all directions. The usable signal in Wi-Fi is the difference between the signal strength of the transmission minus all the interference that crowds out the signal. Ruckus APs, as you can see in this picture, by focusing their energy in a specific direction, dramatically reduce interference levels. Here it's reducing it by 17 dB to further improve the useful signal strength for connected clients. Finally, another aspect of our smart Wi-Fi is that the Wi-Fi infrastructure actively steers clients to the 5 GHz spectrum, which is an ideal approach for dealing with high density. 5 GHz, simply put, it just provides additional spectrum that is likely to be less crowded and less subject to interference from things like microwaves or other appliances. Moving clients to 5 GHz reduces the load on the 2.4 GHz spectrum, which also increases the throughput for devices that stay there. Finally, a very key requirement is a complete BYOD or bring your own device solution. Ruckus has a comprehensive framework for managing BYOD and guest devices that ensures secure connectivity, role-based access, full IT visibility, and a very simple and intuitive user experience. I'll walk through the 4 steps of identify, onboard, secure, and manage. Starting with identity, or identify. Device identification is a key requirement for network managers. They need to know what types of devices are on the network, and in some cases need to identify whose device is on the network. This can be a daunting challenge on a typical campus, but with Ruckus, IT staff can quickly identify which known user is associated with a device, and in the case of a guest user, it can tell what type of device it is, which makes it much easier to find the user. This can save a lot of time for IT staff when they need to track down a specific device, and in aggregate, this information can be very helpful for ongoing network planning purposes. Another feature provided by Ruckus is very simple BYOD and guest access onboarding. For instance, when incoming freshmen first arrive on campus in the fall, or after Christmas when many students may return with new devices, as well as to serve just the ongoing stream of campus guests and visitors, schools need a way to easily and quickly enable secure connections without requiring any IT support and with appropriate access controls in place. Ruckus enables a very simple connection, just like you might see in a hotel, where any user can connect but only gets as far as the connection portal. At that point, if it is a student or faculty, perhaps with a new device or bringing their own device, they can enter their credentials and the Ruckus infrastructure will move them to the appropriate secure SSID. If it is a guest of some sort, then the Ruckus infrastructure can simply let them connect directly to the internet, potentially with some bandwidth or usage restrictions. This is all very simple to configure up front and is a basic feature provided on the Ruckus infrastructure. In terms of policy enforcement, device and user-specific policies can be easily enforced via a 2-step process using the Ruckus Zone Director controllers. In the example shown, a policy named Staff Device Policies is being created that provides different levels of access based on device type. PCs, Android, and iOS devices, as you can see, are given access with specific upload and download speed limits and then mapped to specific VLANs. This policy can then be mapped to the particular wireless LAN for staff, and now there's a role and device-based policy in place that will properly assign and manage new user devices. The last aspect of our BYOD framework is device management. Ruckus infrastructure can prevent password sharing and limit the number of connected devices per user based on their roles and needs. Additional device management may be provided via Ruckus MDM or Mobile Device Management Application Partner, such as FileWave, whose MDM solutions are integrated with the Ruckus to provide a seamless user and IT experience. So Ruckus really has a lot of differentiators that are ideally suited to deliver superior Wi-Fi connectivity on college and university campuses. The combination of adaptive antennas, smart QoS that automatically classifies traffic based on the application and performance requirements, meshing that allows you to easily extend coverage outdoors and to hard-to-reach corners of your buildings, and secure BYOD and guest connectivity so that it's very easy for new users and devices to get connected without requiring any IT configuration support. These all combine to provide an ideal infrastructure for environments that are very large, have high density usage, and have limited IT support. I've talked about many of our key differentiators, but the important question is, how does Ruckus perform in real life? A recent study was published by Syracuse University tried to answer this question by comparing 3x3 3-stream access 802.11n APs from leading vendors, and a summary of the results is shown here. We didn't win every test, but in a controlled, rigorous test environment against 4 other vendors, Ruckus won 5 times as many performance tests as anyone else. Most importantly, we tended to win tests that addressed challenges such as high density, high interference, or long range. We think that performance in these challenging scenarios is really what matters for higher education. You can see the full results of the study on ruckuswireless.com. Ruckus offers a complete portfolio of products to meet diverse needs. You can see our APs on the top row that are intended for indoor use. These range from the high-end 7982 3x3 3-stream access point to a small AP over on the right that's a 7055 that is designed for individual room use in a hotel or a hospital. Most often, in a higher education environment, we would expect people to use the 7982 or one of our mid-range indoor APs, which offer either dual or single band operation. We also offer several outdoor APs, which you can see on the bottom row. These are IP67 rated to work in extreme weather and temperature conditions and come with a variety of internal antennas to meet specific use cases, including a 30-degree focus beam for very high-density applications, such as in a stadium or an arena. On the lower right, the 7731 point-to-point and point-to-multipoint bridge can deliver strong connections for up to 6 miles in a clear line-of-sight environment. These can be used to deliver network services to off-campus buildings or facilities without having to pay for additional broadband connections. We also offer a wide range of controllers to meet different school needs. While each of our APs can also be deployed autonomously, which is without a controller, the controllers provide a central point for managing an entire site or multiple sites and enable certain key features such as meshing. A key capability of our controllers is that they support a wide range of deployment architectures. These can be deployed on-site or centrally, manage one or many locations, and can be in or out of the data path. So no matter how many APs, buildings, schools, or campuses you have, or how spread out they are, it's possible to manage them all from a central location. Ruckus has also released a number of free applications for iOS and Android to help our partners and customers be more informed about their Wi-Fi coverage and performance. These don't replace a full site survey tool such as an air magnet, but can be used by almost anyone to understand how the Wi-Fi is performing. Each of these tools focuses on throughput, which makes it easy for a non-technical user to relate performance to application requirements. SpeedFlex, for instance, is a wireless performance testing tool that can be used to evaluate the performance of an existing Wi-Fi network and identify any issues or needs. It can be downloaded onto an iPhone, and someone can walk around the campus and test throughput. It's as easy as that. SWAT, which stands for the SpeedFlex Wireless Assessment Tool, goes a step further, and it allows you to upload maps or floor plans and then plot your results. It's very simple to use. You can upload plans from Dropbox, the cloud-based free storage service, or you can simply snap a photo of a map and load it from there. Again, these are not professional-grade tools, but they're free, they're easy-to-use applications, and they can help people better understand their Wi-Fi environment. Ruckus is a leading global Wi-Fi vendor. We're the third largest enterprise-class Wi-Fi vendor worldwide and are by far the fastest-growing vendor in the top 5. So you can see we have a broad and growing customer base, including many installations at leading colleges and universities. Thank you for listening. Please contact your local Ruckus reseller or account team for more information, or visit our website at ruckuswireless.com.